All right, so let's try example number 8. In this example, we're going to find the derivative using basic derivative rules. So this one doesn't seem so normal at first, but we have to do some modifications, some manipulations with using the algebra to be able to use some of the rules. So let's begin by writing the function. Now what I'm going to do here is I notice that we have a square root of x. Now remember that when you have a square root of x, there is a power associated with this square root, and this is the power of 1/2. So this is equivalent to x to the 1/2. If you think about it, there's like a index here, and if there's none there, the assumption is that the index is 2. So that means that you have a power of 1, right? That's your power, and your index is your denominator on the power. So therefore, you have this as x to the 1/2, right? Plus 9. Now the other rule that we want to discuss here is that having a denominator of x to the 7. I want to remind you that whenever you have a denominator of x to any power, that you can manipulate the algebra and move this to the numerator by changing the sign of the power. In other words, you're going to have 1 times x to the power of -7. Of course, here you got 1 times anything is always the same thing, so therefore you have x to the -7. So when you move this variable to the top, you're gonna have x to the -7. So it'll be times x to the -7. Now, if you notice here, now it kind of makes that. Now it's consistent with what we know. Now we know which rule to use because now we have powers. So that's the key in this example. That's what we're trying to get from here. A lot of students get lost because they forget that they can write the square root as a power form, or they can modify the expression of a fraction, and to change the numerator to the numerator, you can just change the sign. So anyways, now that we have it here, we haven't done the derivative, and I recommend you not to do it until you completely write the function in this form. That way you're not trying to do this in your head, which it will be very overwhelming. So now that we have this, now we can use the power rule to find the derivative, and along with the constant multiple rule. So you have -7 times, and then now you do the derivative of x to the 1/2, right? And that should be 1/2 x. And then if you think about it, I'm going to write it here. It will be 1/2 and then subtract 1, right? From the power. That's the power rule. Plus 9 times, and then here we're going to take the power rule for this. So it'll be -7 x to the -7 minus 1, right? So remember, you still have to apply the power rule, right? The power rule says that you have x to the n. The derivative of this will be n x to the n minus 1, right? That's another way we can write the derivative of something, right? X to the n prime. All right, so anyways, so let's go ahead and simplify this. We have -7 times 1/2. That will be -7 over 2 times x to the, what's 1/2 minus 1? That's -1/2, right? You can put this in your calculator, and that will give you a -1/2. And then 9 times -7 will be -36. X to the -7 minus 1 is -8. So that's -8 there. All right, so that's pretty much the derivative, right? But we need to make sure that this is written nicely in terms of radicals, and don't have any negative power. So we're gonna go ahead and we're gonna do the same thing as we did before, right? When you want to move something from the top to the denominator, what are you gonna do? You're gonna change the power sign. So we're going to move this to the denominator. Might as well put it in the same fraction bar. Why not? There's no reason why not to, because it's multiplication. So it'll be 2 times x to the 1/2 minus 36, and then we're going to move the x to the -8 over 1 to the denominator by having 1 over x to the 8. So this will be x to the 8. Now notice that the 36 stays on top because this is a product, and the only one that has a negative power is the base value x, right? Your x. Now we're not done yet. We still got to do one more step, and that is to rewrite the x to the 1/2 as a radical. And there you go. So we found the derivative of the function, right? So I want to remind you that first write the function, rewrite the function to make it easier for you, and then once you have that, then you can take the derivative. So be careful how you do this process. Make sure you follow. Once you compromise to taking the derivative, you have to take the derivative of every single term, right? So you can see here that I'm not just doing the derivative of the first term and then carrying the second value here, right? I'm not doing that. Once I take the derivative of this one, I have to take the derivative of that one. All right. Hope you guys find this helpful.